Hi, my name is Aditya. I am the CEO of Automaski, and today I am going to be talking about the only way to create nuclear fusion. The absolutely only way to create nuclear fusion. So let's get started. But before that, a little bit about Automaski. We've been working on complexity theory since late 80s. We solved P is equal to NP in early 90s, got into quantum physics in mid 90s, and within a few years realized this universe is a simulation, and that too a linear order simulation, and that implementing physics won't require of the order of 2 to the power 3n complexity, but rather order n complexity, which is linear complexity. We had developed our rudimentary quantum computer a few years later, but only in 2014, when there were massive publications, we figured out which gates to implement and what algorithms to benchmark and test with. Hence, we implicitly achieved quantum supremacy in early 2015 by virtue of creating the world's most powerful billion qubit infinite precision quantum computer. 2 years back, we simulated quantum gravity with a billion qubits. 6 months back, we publicly launched our RSA 2048 cracking service, available for anyone who cares to pay money and use it. Till then, it was available only to Department of Defenses and agencies around the world behind closed doors. And today, we are working on our quantum gravity computer based on causaloid formalism. Again, the core quantum gravity computer has been ready for years now. We've been playing with it and trying incremental changes, just that we don't know how to make use of it because there is nothing published or available out there which shows how something like a quantum gravity computer can be used to solve real world problems. Before we go ahead, a little bit of a small piece of advisory. Please proceed with caution. If this presentation goes against your belief system, then please ignore this presentation, stop the video, and focus on things you are passionate about. If you are respectful and polite, I would love to answer any questions you might have or listen to your thoughts. Feel free to email info@automaski.com. Our sun. The sun produces heat and light by a process known as nuclear fusion. In the core of the sun, hydrogen is being converted into helium. This is called nuclear fusion. Fusion occurs when two atoms slam together to form a heavier atom, like when two hydrogen atoms fuse to form one helium atom. This is the same process that powers the sun inside its core and creates huge amounts of energy, several times greater than fission. Fusion reactions are being studied by scientists but are difficult to sustain for long periods of time because of the tremendous amount of pressure and temperature needed to fuse the nuclei together. This is a tokamak reactor which is being made in China. You see this round silvery thing, circular thing. That is the reactor. And this is the reactor in which scientists are trying to do controlled nuclear fusion. A tokamak is a machine that confines a plasma using magnetic fields in a donut shape that scientists call a torus. Now, scientists believe that tokamaks are the leading, plasma confinement concept for future fusion power plants. So this is the most popular design of nuclear fusion power reactors. So you will say, but don't we already have nuclear reactors and nuclear power plants? Why do we need nuclear fusion reactors or power plants? Now, yes, we do have nuclear fission reactors and power plants. So let me explain. Nuclear fission occurs when a neutron slams into a larger atom, forcing it to excite and split into two smaller atoms. This is known as fission products, basically breaking up of a large atom. Additional neutrons are also released that can initiate a chain reaction. Now, when each atom splits, a tremendous amount of energy is released. Uranium and plutonium are the most commonly used fuels for fission reactions in nuclear power reactors because they are easy to initiate and control. But the world has very limited quantities of uranium and plutonium. And the energy released by fission in these reactors heats water into steam. The steam is then used to spin a turbine to produce carbon free electricity. But there are problems. The problem of radioactive waste. Though nuclear power plants only emit negligible amounts of carbon dioxide into the atmosphere, its nuclear fuel chain process does produce radioactive waste. I'm talking about fission nuclear power plants. The radioactive waste produced with fusion is not the same as fission, and the two are often confused. With fission, the radiation is alpha particles, beta particles, and gamma rays, which can penetrate your skin and break apart the bonds in your DNA structure, giving you all kinds of cancer. In contrast, in a fusion reactor, the vessel wall is the only part that will be bombarded by high energy neutrons. And if, in the worst case, all the protective layers surrounding the main fusion vessel fail, the neutron radiation will stop as soon as the fusion reaction stops. But in a fission reactor, the cancer causing radiation still exists even in waste materials, which means that extreme measures are needed to bury the waste to keep it as far away from as possible from humans. In the case of nuclear fusion, the activated materials, that is, the metal vessels which have been bombarded by neutrons, can be stored safely for about 100 years, after which the radiation level becomes so low that they can be reused in the fusion reactor again. A little bit about India. Nuclear fission power is the fifth largest source of electricity in India after coal, gas, hydroelectricity, and wind power. As of November 2020, India has 22 nuclear fission reactors in operation in 8 nuclear power plants with a total installed capacity of 7,400 megawatts. Nuclear fission power produced a total of 43 terawatt hours in 2020-21, contributing around 3% of total power generation in India. 10 more reactors are under construction with a combined generation capacity of 8,000 megawatts. In October 2010, India drew up a plan to reach a nuclear power capacity of 63 gigawatts in 2032. This is nuclear fission. India's three-stage nuclear power program. If you see the table on the left, this table shows the deposits of monazite found in India. Around 12 million tons of monazite. Monazite is the source of uranium and thorium. India's three-stage nuclear power program was formulated by a scientist called Homi Bhabha in 1950s to secure the country's long-term energy independence through the use of uranium and thorium reserves found in the monazite sands of coastal regions of South India. The ultimate focus of the program is on enabling thorium reserves of India to be utilized in meeting the country's energy requirements instead of uranium. Thorium is particularly attractive for India as India has only 1 to 2% of the global uranium reserves, but one of the largest shares of global thorium reserves at about 25% of the world's known thorium reserves. However, thorium is more difficult to use than uranium as a fuel because it requires breeding. Breeding is basically done in a kind of a nuclear reactor in which the reactor produces more fissionable material than it consumes to generate energy. So, and thorium is very difficult to use economically also because the global uranium prices remain low enough that breeding is not cost effective. So India is ahead of most of the world in thorium research, and India estimates that the country can produce 500 gigawatts of electricity for at least 4 centuries using just the country's economically extractable thorium reserves. And the first, fast breeder reactor has been repeatedly delayed and is expected to be commissioned by October 2022, which I'm not sure it has happened because we are already in February 2023. And India continues to import thousands of tons of uranium from Russia, Kazakhstan, France, and Uzbekistan. Now back to fusion. The problem with tokamaks. The temperatures inside a tokamak must reach 150 million degrees Celsius or 10 times the temperature at the core of the sun in order for the gas in the vacuum chamber to reach the plasma state and for the fusion reaction to occur. One of the challenges of fusion tokamaks is how to keep the core of the plasma hot enough that fusion can occur while at the same time preventing the tokamak walls from melting from that heat. This problem is even more difficult if instabilities at the plasma edge release energy in short bursts instead of a steady flow. Large tokamaks must operate without edge instabilities in order to avoid potential damage. Also, tokamaks are currently unviable as we need to put in more energy than they output. And also, currently the fusion reaction in tokamaks is unsustainable as the plasma develops cold spots and the reaction dies down, and nobody can figure out why this is happening or how to prevent it. The only solution, the only way we can successfully create controlled nuclear fusion. Now, basically, the bottom line is that nobody knows how plasma behaves at 150 or 200 million degrees centigrade. The only way we can solve all the problems we are facing with creating nuclear fusion is by simulating plasma at 200 million degrees and then reverse inferring how we should be designing the reactors, materials, etc. Sadly, that's the only way it can be done. Or else we can keep making trial and error attempts for decades, centuries, or even till eternity in the hopes that someone across the world will hit a fluke and figure out how to get this to work. But such quantum simulations would require a universal quantum computer with millions or billions of perfect qubits and gates, or a quantum annealer with a quintillion qubits, which only Atomasky has, which no one has currently and nobody can make in the next 1,000 years. And I'm old, exhausted, broke, frustrated with idiots, given up in life, and going to retire this year in all probability. Tough luck, guys. Congratulations and enjoy. You might not want to believe it, but either way, this is the way it is, and it is not going to change. You take the blue pill, the story ends. You wake up in your bed and believe whatever you want to believe. You take the red pill, you stay in Wonderland, and I show you how deep the rabbit hole goes. Remember, all I'm offering is the truth, nothing more. Thank you, and hope you have a nice day.